If we look through a diverging lens, this lens is concave. The curvature is going in toward the, you can't really see it, but it's going in toward the casing. Let's look at the image of the lens here. Okay, this is the basic shape of the lens. Of course, this lens is just cut in half, and it's not concave on both sides. But if we look at the image that we get, we see that it's smaller, although as we get closer and closer to the object, the image does get bigger, and as we move away, the image, you see, gets smaller. If we look at the writing down here, we see the writing gets bigger, and then as we come away from it, it gets smaller. You notice that the image does stay in focus. It's clear wherever it is, but it's not the same size, but it's also upright. Now let's think about this diverging or convex lens. Okay, here's the lens. Parallel rays come into the lens, and what happens to them? Well, they get diverged. They get bent away from the axis. The axis beam will come straight through, but any beam away from the axis gets bent away, and the further it is away from the axis, the more it gets bent away, because the more curvature it encounters. So the greater its angle of incidence, and so forth. Now the focal point for such a lens is on this side. It's the point at which the parallel rays converge. Well, they converge here. So there's the focal point. Now the rays aren't really there. It's just where they converge. And if you're out here looking, it's where they appear to be coming from. Okay, so that the rays appear to be coming from the focal point. All the parallel rays that come into the lens will then appear to be coming from the focal point. Okay? And that's what we've written down here. Okay? So, let's think about what happens when we've got an object. Here we have our object. It's at some object distance. The point of the head rays come in parallel and get diverged. The central ray goes right through the center without being changed. So if you're on this side of the lens looking at the object through the lens, the top of the head ray appears to be coming from this, along this line. This top of the head ray, of course, appears to be coming along this line, so that the top of the head rays appear to be coming from this point down here. So this is the point where the rays meet. Now, if we look at a close-up, we see that we get a virtual image, and it's upright. Okay, the feet are still on the axis, the head is up here, but it's very small. And of course, that's what we saw. When the lens got far away from the paper, the image got smaller. When the object distance increased, the image got smaller. That's because the greater the object distance, the less angle you've got here. The closer this line, therefore, is to the axis line, and the smaller the image will be, because when this ray meets, it's got to cross this line. If this line was very steep, it would meet at a higher point, as you can see by doing a little bit of ray tracing. Now, how do we symbolize image distance, object distance, and so forth? Well, let's look at it. Actually, in the case of the diverging lens, the focus, which is on the wrong side of the lens, okay, remember the focal point is over on this, let's come up, is over on this side of the lens. We're going to say the focal distance is negative, and we're also going to say that the image, well, we're going to say that the image distance is positive. The image is always, the object distance is positive. The object is always on the right side of the lens. The object is always positive. But the image is forming on the wrong side of the lens also. So the image distance will be negative and the focal distance will be negative. And that's what we're talking about here. Okay? F is negative because we're focusing on the wrong side, the virtual side of the lens. The image position is positive, so that this 1 over O is positive, but 1 over F is negative, which means that this whole side has to be negative because it's got to be equal to 1 over F. Now, since this is positive, there's no choice but for 1 over I to be negative. So we see that the image does have to form on the negative or the wrong side of the lens, and that we're going to get a virtual image.